We have already discussed the piezoelectric effect. Now we are discussing the piezoelectric transducer. In this piezoelectric transducer, we have a force summing membrane and a base. Our piezoelectric crystal is kept between this force summing membrane and the base. Through pressure port, when we are applying the force on it, then here the voltage will be generated across the piezoelectric crystal. How? Positive charges are coming one side, negative charges are coming one side. This voltage can be calculated. Now this piezoelectric crystal gives the voltage in the range of 1 to 30 millivolts for the unit acceleration. That's why we use this piezoelectric material for measuring the force between 1 Newton to 200 kilonewtons. Example, you wanted to know how much force is being exerted on this material. If we connect the piezoelectric material to it, when the force is being exerted, accordingly the voltage will be displayed on our meters. With the voltage displayed on our meters, we can measure the actual force. There is a formula, Q is equal to Kf. K is constant, F is force, and Q is the charge. We know for the capacitance, C is equal to epsilon A by D. Epsilon is the permittivity of the crystal, how many electric field lines can go through the crystal, and A is the area between the two surfaces, so positive and negative charges are being formed on two surfaces. Okay, what is the area of that surface and the distance between the two surfaces. Now we know capacitance Q is equal, when we want to know capacitance, we generally use the formula capacitance C is equal to Q by V, or Q is equal to CV. Now we want to measure the output voltage at the crystal. So output voltage is nothing but Q by C. Q is nothing but Kf and C is nothing but epsilon A by D. If we take the K by epsilon common, then D, distance between the two surfaces, F force is being applied, and A is the area of the surface. Now F by area, force by area is nothing but pressure. So finally output voltage is nothing but G, voltage sensitivity. This voltage sensitivity depends on how the piezoelectric material is cut. When the cut of the material is changing, the voltage sensitivity is varying. Okay, G, it is constant until we change the piezoelectric material. Now, D is the distance between the two surfaces and P is the pressure being exerted. If we heat the piezoelectric material above Curie temperature, this will lose its property. So the disadvantage with it, piezoelectric transducer is, it is temperature sensitive. If we increase more temperature, even it may lose its property also. The temperature where, after that if we increase the temperature, it loses its property is called as Curie temperature. And output current is very small because output impedance is very high. That is one disadvantage. And it is applicable only for the dynamic changes. For the static change, we cannot use the piezoelectric transducer. For transient fluid pressure and for accelerometer applications, we use the piezoelectric transducer.